Hi, I'm Alex Williams of the New Stack with our series of interviews from the OpenStack Summit in Austin, Texas, brought to you by GoDaddy. GoDaddy is transforming itself with the development of a new stack infrastructure and an OpenStack service for its legions of small business customers. Learn more at GoDaddy.com. Hey, Alex Williams, the New Stack, here at the OpenStack Summit. It is Wednesday. We're past the halfway mark here. We had our pancake breakfast this morning, and now we're here with JR Rivers, who's going to talk with us a little bit about Cumulus Networks. Cumulus Networks, one of the more interesting companies in this space, which really has, help people understand the context of Linux, in the networking, in terms of networking. And with me is Lee Calcote, and Lee has been working with the New Stack and helping us better understand this new emerging space. And so I'm going to let him ask most of the questions, but I did just want to start and ask you, JR, what is this new stack of networking? We've been asking this question here at OpenStack, just to help us get a better context of what it means now. Now that we have more container-based architectures, we have lots of different new emerging types of platforms developing. We're just curious on how you see that in the context of, for example, OpenStack.
All right. Well, thanks for having me on the show. If you look at a lot of the physical and like kind of the lower level constructs that we use in networking, like IP and Ethernet, these are really well understood and concentrated. And in the past, people would rely on the networking hardware vendors to build cool new hardware to enable new functions and new interactions and interconnect models. And what we're seeing occurring now, all over the place, is that people come up with a framework in which they want to, connect systems, and they want to make those malleable. They want to change them over time, and more often than not, we're starting to see those end up on hosts, on servers. And then using the physical networking is kind of much more straightforward. It's very, very much IP centric and very oriented towards high capacity interconnect models. So what that turns into is a kind of a breakdown of what used to be a single vendor ecosystem or a single type of vendor ecosystem, and a broadening into things that occur inside of frameworks like OpenStack. They have Neutron, that's the networking model for OpenStack, and it's got a lot of really built-in cool characteristics. There's a different model for Docker, there's a different model for Kubernetes. Those are all software-based. They all use IP fabrics. So you're seeing this big upheaval occurring in the space just based on that breakdown.
JR, very good. So just you mentioned a couple of different emerging networking models, and those being sort of software-based in and around. How does Cumulus Networks make those better or sort of fit into those landscapes?
Right, so we both make them better and we don't make them worse, if you get what I'm saying. So as a company, I've been in the networking world for a really long time, and and on the compute side. So you saw this coming 10 or so years ago, and when you do that, you recognize the physical networking. You want it to be really simple, high capacity, really great IP. Don't add a lot of bells and whistles, because you don't want a lot of bells and whistles there. You want to make it really simple, predictable for people. So if you're working on Docker networking, they just work on it. They know how IP works, and as long as we make IP work really well, they love it. So we focus on that, make things simple to deploy, get out of the way. If someone's going to stand up a really high, big fabric, we want to make it easy to deploy, easy to manage, in that, kind of in that context. The flip side is there's, by working with each of these people, we're able to give them little pieces of technology or work with them on adding things to the Linux kernel that kind of further the movement. An example of something that happened is about two years ago or so is the community got together and added a VXLAN device to the Linux kernel. It was really, really huge to do that, because VXLAN is what a lot of these models use when they're building a data center overlay network. It's a tunneling mechanism, and it's built into hardware. It's built into the switching hardware, built into the NIC hardware. with offloads and everything. So it's a really great tool that everybody wants to use inside their networking model. And we added that into the Linux kernel with a whole bunch of other people. It was a great enabler, and it also made everything more simple. Because people, up until then, people were kind of inventing their own tunneling protocols and trying to use ones that were not quite architecturally good for them to use, just because that was the only thing they knew.
Yeah, or some organizations were trying to create their own standards around how to do those overlays, and so.
Yeah, right.
Just speaking about VXLAN real quick and kind of VTPs and public clouds, I guess, I hadn't yet looked at, you talked about offloading being a component of just kind of, commonplace now in terms of VXLAN offloading. And I guess, within public clouds and maybe some of the bigger ones out there, are you aware of whether or not they're, and I recognize a lot of them don't necessarily expose these details to the public, but are you aware of, a lot of times, whether or not they're taking advantage of that type of offloading? A lot of times as organizations go to use a hybrid cloud and go to establish one, those overlay networks really come in handy in terms of connecting on-prem to public cloud.
Right.
And I guess I just didn't know if, for the most part, people were having to do that VXLAN overhead in software in public clouds, or if you were aware of public clouds running offloading.
Yeah, so obviously I can't use any names here, but we know that there's one that's using VXLAN as their tunneling mechanism. There's one that I don't know anything about, and then there's another one that we know for sure uses a homegrown thing that they built a long time ago, long before VXLAN came to the market. But it basically has a lot of the same behaviors and characteristics as VXLAN.
Going back for a second, just one of the things that you talked about some of the intelligence then going into the software of the networking and sort of beginning to rely upon those more of the hardware switching just for IP-based connectivity and a bunch of throughput and obviously some core routing in there. And I just realized a little bit ago that you and I have both spent some time at Cisco, and certainly a bunch of different themes over time there, but one of the ones that I've carried with me was the notion that particularly in the IoT space, that the further you can push that intelligence out to the edge, kind of the better, and the smarter decisions you can make kind of local to where the traffic initially needs to be routed and switched to. And I guess I wanted to take that kind of that concept and make an analogy here and see if this resonated with you or not, but just as a lot of that networking smarts, if you will, goes into software, is that sort of the same type of a concept of pushing the intelligence out to the edge or down to the, I guess in Cumulus Networks space, all the way down to the hypervisor, down to the server itself?
Right. Inevitably, there's in the field of networking, there's always been this balance of kind of concentrated intelligence, or some people call it big core or heavy core versus light core, where you just the core, the inside is just a lot of bandwidth, really, really fast, easy to deploy, and you put the intelligence around the edges. And there's always been this great big battle. Some of it is technically oriented, like what's easier or hard to do. A lot of it is actually money oriented. Like if I can build a really big box that nobody else can build, and you have to buy it from me, then I would really prefer to use that model, right? But what we're seeing now is this, multi-exponential explosion in compute and interconnect capacity, changing all of these models, right? Like look at your phone, for instance. It's a great example of this now. 15 years ago, what was your phone? It could make calls and some SMS, right? Now it's your walking computer, right? There's a lot of people that didn't want that to occur, right? Their business models shifted and changed. The PC market is drying up and right in our faces, because the phone is now, or the tablet is now the computational model, right? With that said, the telcos are in this really weird space where bandwidth is king, right? They really want to provide like value-added services to their customers, but in the end, all the customers want out of them is bandwidth. Right? Connect me. I need 4G, 5G, whatever. It's because I don't need, I don't need fancy features. I don't gold, silver, bronze service from you. I just need bandwidth.
So I know, going to one of the things you said, I know Alex has touched on this a number of times before, but you were talking about, so essentially that shift then of kind of smarts to the edge. If we talk about at least a term that I know that you guys use, which is, and I may get it's net DevOps. Or
Yeah,
it's not DevOps
right.
Net, or it's not.
Yes, yeah,
But
right.
and I think the DevOps Sec folks have gotten in a confusion as to where the Sec lies. But as we look at that space, I know configuration management, I think, kind of comes as people go to shift and interface with the network in more software-defined ways with REST-based interfaces, hopefully more scalable ways of interacting, more friendly ways, more secure ways, less CLI. So NetSecOps comes in there, and so does configuration management. I noticed that you guys have got some integrations with so the top tools in that space.
Yeah, right.
And I guess wanted to talk about that in general, and then toss a specific question your way around HashiCorp's Terraform, which is in some respects of the same ilk in terms of being a configuration management tool.
Right.
And whether or not as you guys have engaged with customers, if there's been an ask for an integration with that tool as well. So.
Right. So the great thing for us is we don't actually have to integrate with any of these tools. We like I said, I've been in this world for a really long time, and you can kind of see the writing on the wall ahead of time. The industry standard hardware, this ecosystem that is developed around Linux, and so that's why we structured the company the way we did. Cisco couldn't do this because it destroys their business model and everything and all their technology that they've built up from. So you have to start a new company to kind of move the industry forward. But we chose Linux. We literally hardware accelerate Linux. We're like RHEL for switching. So like HashiCorp, Terraform will just work on the platform. Chef, Puppet, Ansible, they just work. Now, kind of digging into net DevOps, it's really interesting. In the very, very early days of Cisco, what the CLI did is it put in guardrails for customers. It's like under the covers, there's all kinds of really cool stuff that you can do in an early Cisco platform. But this early CLI was there to make it was kind of a user's guide, built-in user's guide, and it also kept the customers from doing stupid stuff. Right? Now they can still make mistakes and make configuration problems, but there's a whole bunch of things that they were blocked from doing. And then if you look at Cisco CLI then versus Cisco CLI now, it's ginormous. It's really, really hard to consume. There's a lot of stuff in there, a lot of things that you have to learn. So the guardrails have gotten much looser. With Cumulus Linux, we took the guardrails off. You can do on the platform anything that you want to do. And what people then, and you can say, oh wow, scary world, you've taken off my guardrails. Well, that's where configuration management tools come into play. What we've done is we've removed artificial guardrails. The right thing for you to do is to put your own operational guardrails in. And so let's use Ansible as an example. You go in with Ansible, you decide, okay, we're a layer 2 architecture, so we're going to do things like add VLANs, delete VLANs, turn ports on and off. You set up what are the operations you expect to do inside your framework. Maybe there's 20 that you actually want to do and want people to have freedom to do. Well, you set those up in your configuration management tool, and now you've put your own guardrails in. They're way smaller than what was available via CLI, and it's tuned to your business. And now you can give more people access to that as well. So if you set that up, a developer can go through and say, all right, I'm going to turn on a new VLAN, or I'm going to delete my VLAN.
I guess a couple of questions in there. One just really quick one was in terms of those guardrails. To what extent do you guys continue to have existing guardrails within Cumulus Linux? Just is it full root that you open up and you just how do you?
Exactly. I mean, the philosophy that we have, it literally is you log into a bash prompt and it's a server. It comes up, everything's there. We do smart things, like we have appropriate nice levels for processes and put memory limits on things that we're running and those sorts of things there. Customers can feel free to change it if it makes sense. Very, very few do, but by kind of opening the full kimono, it allows them to look at it and feel comfortable with what's going on.
So I have a question about thinking back to what you said at the top of the conversation about constructs. So what are the new constructs? We're seeing a lot of different new constructs that are taking us to, or having us think about things differently. For instance, instances, I think, is a good example of a construct that, had not been really known about, 3 or 4 years ago. Right?
Sorry, can you say that again?
Instances, like a compute instance, for example.
Yeah.
Right? the clusters has a different kind of context to it.
Right.
What are some of the new constructs that you guys think about when you're thinking about helping customers make sense of this, or just trying to communicate among yourselves about what these new concepts mean?
Right. I think the biggest thing that I see that kind of exists in general is, in the old days, and actually not that long ago, but you would buy a server or a Sun Microsystems workstation or whatever, and you'd give it a static IP address, and you put it on the network, and like renumber, and the servers had well-known names, and people would code IP addresses into applications and that sort of thing. In this world of super flexible computing, whether it's container-based or VM-based or whatever, those go out the door. So, addressing is dynamic, naming becomes really important, being able to tie services to namespace is also important. So how people go about solving those problems in various environments is kind of an interesting and evolving construct. And again, what's really cool about what's going on right now is people are solving in a lot of different ways. There's no standards body that's defining it. There's no, the standards bodies really are the technology providers, right? Docker solves naming and addressing a certain way. Kubernetes does it differently.
Right.
Everybody's using IP as a fundamental construct, but that naming mechanism is independent.
How are the new concepts around isolation, for example, changing some of the constructs? So I'm thinking about containers in particular.
Right. Yeah, that's an interesting one. I would say containers exacerbate an already existing problem that you have with virtual machines. That I talked about static IP addresses back in the good old days. That was a big, heavy piece of physical stuff that was really expensive that nobody ever wanted to move, right? And so that it was okay to give it an IP address and have it be fine. Virtual machines kind of come and go at a certain pace. Containers come and go at a much, much faster pace. And pragmatically, when you look at a container-based application or container-oriented application, there's a lot of small instances, and people create scale by parallelizing these instances of a particular service. Right. And so you see instances, using the term you phrased, coming and going at a pretty blinding pace. So being able to, they just exacerbate that problem and make people solve things in a better way. Kind of back to a dumb example, there's this technology called dynamic DNS that's been around for almost 1 billion years, where if I come up and I have an IP address, but I know what my name is, I'm JR, I look and I find my IP address, I can go to the name servers and say, hey, you can reach me at this IP address, I can register my relationship to my DNS server, and everybody can now find me. That's been around, hardly anybody ever used it. It doesn't work that way anymore. In the container world, that is the model. Like, you come up, you tell everybody, hey, this is where I am now, when you're looking for me, this is how you get there.
Maybe take a step at and a look at monitoring and kind of how that changes in a software-defined networking world. Yeah. I understand you guys have an S-Flow agent in Mon, right. But I also understand that Cumulus Linux is just that, is a full Linux distro and is capable of having other agents deployed as well. I just wanted to get your thoughts around, or at least what you're seeing with your customers in terms of how often they are running other agents, whether those agents are for APM like New Relic, or if those agents are for more sort of classic network monitoring.
Right. Yeah. So I'd say most of them are oriented around operations. So like you said, kind of classic network monitoring. If you break it down, you have architecture, which people do kind of in their heads or on whiteboards. Then you have deployment, monitoring, troubleshooting, and lifecycle management. So those are the five pillars of operations. Those last four are places where people will install additional software on a switch to fit into their operational model, because they've built one around servers. If you go into like a normal company today, with any degree of automation and monitoring, what you'll always find is there's an infrastructure they use for compute, and there's a separate infrastructure that they use for networking. Right. Right. And so because we're a Linux platform, it all just folds in. I mean, I don't know. Every customer I talked to at the show today said, or not today, this week, love what you guys are doing. Now I can use Sensu for my monitoring tool, or I can use InfluxDB and Grafana or whatever they want to use. They can now use, because that's what they were using for their servers. A whole realm of monitoring options open up, which are way more sophisticated than what people were using in the past. So, there are still a lot of people that use SNMP because that's what they had tooled in, previously. But oh my God, has that protocol been broken for a long time? Forget the protocol, the model's been broken for a really long time, and networking people just suffered through it. And now, the sysadmins are kind of blowing it away. It's rewarding and challenging at the same time to see a sysadmin get a hold of one of our platforms when they're building an OpenStack cluster, throw up a great monitoring solution, and then watch the networking engineer come by and go, oh my God, how did you do that? And they said, yeah, well, I did that this afternoon. Yeah. They're like, holy crap, I've been using all these tools that took forever to cobble together, and they don't look anywhere, they're not nearly as good.
They weren't as secure, they weren't as easy to integrate with. They didn't, they weren't as nimble as what you were describing about containers coming up and going down.
Right.
Imagine if someone was trying to monitor those, where they are, what their IP is, maybe what their port is via SNMP,
right.
And just how static those MIBs can be, and just...
Well, just the pull time, you can't pull it fast enough by definition. But you kind of, what's weird about this ecosystem is because there's so many pieces of technology that exist, putting great big wrappers around a lot of it is sometimes counterproductive, meaning like for us as a vendor, trying to say, hey, we're going to give you the best network monitoring solution ever is counterproductive because there's so many different, it's inevitably the customers operate, that customer's operational model is what we need to fit into, right? Back in the old days, HP built OpenView, right? And people built operations around using HP OpenView.
Right.
In that networking silo. That world is gone.
Right.
Right?
Right.
Someone's standing up OpenStack, okay, I've got my OpenStack, I'm using Horizon to do a bunch of stuff, around kind of looking at the OpenStack perspective. I probably want to monitor from the side as well, because in case something goes wrong, I'm on the hook to getting it fixed again. But I'm going to put together what my own tooling is for that, and it's not that hard these days.
So, so you talk about the sysadmin who surprises the network engineer, who with what they've done. That speaks to a simplicity that the system administrator can grasp, right? Due in part to abstractions and such. What are the as Adrian Cockcroft likes to say, is like if you squeeze a balloon, right? You're going to start. The air has to go somewhere, right?
Right.
So as we're squeezing this this balloon around, this new kind of networking, where is the complexity going?
The complexity is going, into things like OpenStack or into a container deployment model, a Mesos or a Docker or a Kubernetes or something like that, and that's exactly where it's going.
Yeah. And
then it's going there, and to some degree, it's going into the applications themselves. So when you look at a services or microservices based application, it fits into development teams' interactions better than monolithic software does, but there is additional complexity.
And how is that complexity servicing?
That's an interesting question. Let me try and ponder the answer. There are two clear ways. Is the ephemeral nature of almost everything, right? So nothing is 1,000% predictable. Like, again, rolling back 15 years when you had a workstation on your desk or a server in a rack and it was just one server, things were incredibly predictable. When you went home at night and you woke up in the morning, that server was probably still going to be there. And if it wasn't there, you could tell because there was a gap or a dust frame around your table. Now when you look at a virtual machine or a microservice, these things come, go, it's a very, very dynamic and ephemeral environment. And so being able to understand what happened at that moment in time when you think you encountered a problem is super important. It's also, when you look at writing applications, you can have a development team where you say, let's say you have 2 people are working on some storage, synchronization service. 2 other people are working on some web front end service that you're deploying. That's why that's one of the reasons why container architectures work really well for applications, is because you can have small teams working on
Right.
each service, and then the services just connect to each other. They still have to talk. In a monolithic application where you opened it up, yeah, it was really hard to compile, it was really hard to make changes to small places, but you could see all the code in one spot.
Right. Now it's a component environment.
Right, exactly. So you have to trust what your other components are, you have to understand them. And so that complexity rises. But then as humans, what we always do is we put shrouds around things to reduce that complexity, right? To put
Right.
it in a box that you can understand.
Right.
So that's why we have things like APIs.
Right.
A container service, or like anything else like that, you have a set of APIs that you will work against, and you publish those. And so that's how you hide the complexity of what's inside for most people.
So JR, we're here at the OpenStack Summit, and just a question around how you guys work better. Why it is that when someone's deploying OpenStack, they do well to have Cumulus Linux there. Just how it is that you integrate in and.
Right. Well, we have a experiment that we did with Dell and Red Hat. We published a white paper on our website and issued a press release and all that. But it showed kind of in a nutshell why this is important. With a really small amount of time, they stood up a really large production scale cluster, like 300 nodes. It all used kind of classic Linux all the way down tooling. So for the cluster admins, which are typically system administrative backgrounds, it's really easy, really super straightforward. And that's kind of our biggest value add. Inevitably, from a feature and function perspective, we have the same features and functions that a Cisco or an Arista or anybody else has. Right? It's really that integration and operation model where we're very and vastly different than the rest of them. And we're really tuned for environments where sysadmins are on the hook for standing up and operating infrastructure elements. So Hadoop clusters, OpenStack clusters, combinations thereof.
Gotcha, and I think that speaks back to that net DevOps kind of shift as well.
Exactly right.
Well, and just exploring that further about the integrations with OpenStack, is there, when OpenStack is running on top of Cumulus Linux, is any of that exposed in the Horizon user interface? Or is there a Neutron plugin that you guys have, or
Right, so almost like everybody else, we have an ML2 plugin that you can use to instantiate VLANs if you're using a layer 2 networking model, which a lot of people have used. Neutron has kind of natively built-in overlay network virtualization now. So some people like to do that in an experimental phase or maybe a low scale type framework. And then there's, we'll call them SDN type companies like a PlumGrid or a Mutakura or others like that, a Contrail, that will provide a more rich, a Conda, a more rich networking software service chaining type infrastructure for customers, and we peer with all of those guys. So we have technology, not just channel partner and marketing logo relationships, but we have technology integration relationships with all of those people. And so our goal in general is to get the physical networking part from the customer's perspective out of the way. Like, pick your tools, understand your business model, don't let us be your deciding point for you. We're going to make it so you pick whatever you need to use, and we'll be able to support it.
Makes sense, and you guys are at that lower, OS level, a lower level that.
Right,
got
exactly.
It.
And we just make it, like I said, easy for the cluster admins to do what they need to do.
Well, good. Well, that takes us up to about a half hour in this discussion, and I just want to thank you, JR, for spending some time with us and talking a little bit about Cumulus and these new concepts of networking that we're just beginning to learn about here at the NewStack, so really appreciate helping us understand it a bit better.
No, thanks again for having me. It was a really good conversation.
Thank you.
All right, take care, guys.
Thanks, Lee.
Thank you, JR. Thank you, Alex.
All right.